In this video, we're going to learn how to factor complex trinomials. In our previous video, we learned how to factor simple trinomials, which remember just means that the number in front of your x squared term, the coefficient of the x squared term, was 1 or could be factored out. And that's the first question you want to ask yourself here. Can you factor out that 3? So in other words, are 5 and 2 both divisible by 3? And in this case, because they're not, that's what makes this a complex trinomial problem. So how do we factor a complex trinomial problem? And factoring it actually follows some of the same steps as simple trinomial problems, but there are some additional steps that you have to consider as well. The first thing we're going to do is similar to how we did this before. We're going to write out MAN, which remember stands for multiplication, addition, and numbers. And normally we would try to multiply to the last number, so the positive 2 over here. But because this is a complex trinomial, we have to multiply that 2 by the 3. So we need to multiply to 3 times 2, or 6. And as always, we're adding to the coefficient of the x term, which is 5. So we need two numbers that multiply to 6 and add to 5. I'm just going to look at my factors of 6, which two numbers that work would be 3 and 2. So our two numbers are 3 and 2. They multiply to 6 and they add to 5. The next thing I'm going to do in my next line is I'm going to replace the 5x with 3x plus 2x. So my next line is going to look like 3x squared plus 3x plus 2x plus 2 is equal to 0. So the 5x is getting broken down into 3x and 2x. Then what I'm going to do is I'm going to split this equation right down the middle, and I like drawing boxes around it. I'm going to separate my first two terms from my last two terms. And the point of doing this is I'm grouping them together so I can common factor the first two terms and the last two terms. So looking at the first two terms, we have 3x squared plus 3x. We're going to ask ourselves what's common between them. And they're both divisible by 3x, so I'm going to pull out a 3x, and in brackets, I'm going to get left with an x plus 1. And then for my last two terms, what's common between those two? So I have 2x and 2. A 2 is common between them, so I'm going to factor out a 2, and I'm going to get left with an x plus 1. As a quick check here, you want to make sure that your two brackets are identical. So in this case, they're both x plus 1. If they are not identical, we may have made a mistake in factoring. But since they are, we're good. So for our next line, what we're writing out is the common bracket, x plus 1 is one of our brackets. And our second bracket comes from everything left over. So we have a 3x plus 2, and that's going to make up our second bracket here, 3x plus 2. Now the end of this works just like a simple trinomial. We're going to take each bracket and set it equal to 0. So we have x plus 1 is equal to 0. And solving for x, we're subtracting 1 from both sides. We're getting x is equal to negative 1. And then for our second bracket, we have 3x plus 2 is equal to 0. We can start by subtracting 2 from both sides, which brings us to 3x is equal to negative 2. And then divide both sides by 3, and that gives us x is equal to negative 2 over 3. So in this case, we know that our solutions are x is equal to negative 1 and x is equal to negative 2 over 3. Those are both the x-intercepts for this question. All right, let's look at another example. So this is our second example. Again, we're going to start by asking ourselves, can we common factor anything out? 6, 5, and 8 are not divisible by the same number, so we can't simplify this any further, and we can go straight into factoring. I'm going to write out MAN, And remember, I want to multiply to -5 multiplied by that number in front of the x squared term, so multiplied by 8. So in this case, I'm trying to multiply to -40, and I'm trying to add to -6. So let's think about two numbers that work. I'm just going to consider factors of 40. I'm thinking 10 and 4 could work. And since we're working with a -6, we're trying to add to a -6. If we make the 10 negative, that'll work. So -10 and +4. And remember my next line, I'm just replacing the 6x with -10x plus 4x. And then we have our -5 at the end. Then we're going to split this in half. So I'm just considering my first two terms separate from my last two terms. Then we need to common factor. So what's common between 8x squared and -10x? They're both divisible by 2 and they're both divisible by x. So I'm going to take out a 2x, which is going to leave me with a 4x minus 5 in the brackets. And when I look at my last two terms, there is nothing common between them. They're both divisible by 1. So I'm going to put a +1 here just as a reminder. And my bracket will just be 4x minus 5. In my next line, I'm going to do a quick check. So 4x minus 5 is the same. Those two brackets are identical, which is perfect. That's going to form one of my brackets. So I have 4x minus 5 as my first bracket, and my second bracket will be 2x plus 1. And then set each bracket equal to 0 and solve. So my first one, we have 4x minus 5 is equal to 0. We're going to start by adding 5 to both sides, which makes this 4x is equal to +5. And then divide both sides by 4, which is giving me x is equal to 5/4. My next bracket is 2x plus 1 is equal to 0. So first I'm going to subtract 1 from both sides, giving me 2x is equal to -1. And then divide both sides by 2, which is giving me x is equal to -1/2. And that's how I'd solve that one.